Hello. Hello and welcome, everyone. My name is Danielle Flug Capolino. I am a third generation Technion supporter. My late grandfather, Joseph Gerwin, was a very passionate supporter of Technion and almost equally passionate about food. My mother, Laura Flug, and I proudly continue in both of these traditions. I have a background in public health and nutrition, but I'm currently active in managing the Technion Angels, a network of investors who are interested in early stage companies coming out of Technion and other Israeli universities. Although we are not affiliated with ATS, our mission is to do well by doing good, and we give back to ATS through our investments to provide a new avenue of investments into Technion. I'm delighted to be joining today's webinar entitled Feeding the Future, Technion's Ingenious Approach to Sustainable Food Tech, both because I have a personal and professional interest in the subject and because of how important this subject is, not only to Israel, but to the world. Science has made it clear that the world's food system is reaching a crisis. Waste, overfishing, deforestation, greenhouse gas emissions from farming and more are destroying our planet. And as the global population keeps growing, food security is fast becoming one of the major challenges facing humanity. Feeding the world today and tomorrow in an effective and sustainable manner is no small feat. It requires creativity and ingenuity to be coupled with state-of-the-art infrastructure and top engineering and scientific know-how. The Technion's Faculty of Biotechnology and Food Engineering is Israel's primary source of food engineers and is one of the few faculties in the world that combines the disciplines of bioengineering, food science, technology, and life sciences. The faculty will now be home to the Carrasco Food Tech Innovation Center, whose aim is to provide solutions to the unmet challenges of sustainably supplying a healthy, tasty, and nutritious diet to a growing world population. It will serve as a hub for entrepreneurs, students, and industrial partners, and will include state-of-the-art facilities for outstanding researchers who are conducting vital, basic, and applied research in a wide variety of food engineering areas. I am delighted to be joined by a few people who will be tackling these issues, and I am very honored to say that I know some of them, two of them personally. Professor Marcelle Machluf is the Dean of the Faculty of Biotechnology and Food Engineering and the head of the Carrasco Center. Professor Ester Segal heads the Laboratory for Multifunctional Nanomaterials at the Faculty of Biotechnology and Food Engineering and is also Technion's Deputy Vice President for Research. And Professor Uri Lesmes, who heads both the Technion Lab of Food Chemistry and Bioactives and the Food and Health Innovation Center. Thank you all for being here today. Just a reminder, we'll have time for questions after all of our guests speak. Please use the Q&A function on the webinar screen to submit your questions, and we will get to as many as we can. Now it is my pleasure to introduce Professor Marcelle Machluf. Professor Machluf is well known for her work in the areas of tissue regeneration and nanoghost drug delivery. But today we're going to hear about your work in the food tech arena. Thank you.
Hello, everyone. Thank you for joining us. As I was introduced, I'm the Dean of this faculty, the Faculty of Biotechnology and Food Engineering. And I'm pleased today to show you how this faculty play a major role in Israel innovation in the terms of food engineering and also in biotechnology. But today discussion will be around the food engineering. So as mentioned before, our faculty is the only faculty in Israel which their graduates are graduating in food engineering and biotechnology. And in terms of the food engineering, we are the only one that supply the engineers of the future for all the company. I'm talking about the traditional company, but also the startup company that are rising very much here in Israel and all around the sustainable food and the culture meat, as we know, or culture milk, as you will hear later on. So in our faculty, the majority of the faculties are food engineers, but also combining biotechnology, as I mentioned. And actually, we are giving to our students the best and innovative research that we can have and can facilitate to them. And also the courses that we are giving are the courses that will lead the technology in the future. And we are covering from different aspects, from microbiology, from genetic engineering to chemistry, chemistry of food, and also sensing food, taste of food, and also in terms of safety of the food, like biosensors and other. So actually the students get all the pack that we need for them to be the engineer of tomorrow. Just to give you an example, our faculty members are not only engaged in research and in science, but they are also behind a lot of patents that recently came out from the faculty, particularly lately, also in the food area. As you see here, we have a lot of patents. We have a lot of patents that is approved, and some of them are already translated to different startup company. For example, we have the NanoGhost. This is a company that I established 2 years ago, but it comes from the area of biotechnology for cancer therapy, but also the Skinopa, a development by Boaz Mizrahi, and also other technologies that currently are under negotiation and under, let's say, term sheet agreement with the Technion to go out and to be startup companies. We also have in the department unique project that you will not find anywhere else in Israel. And Uri will talk later on the Foodio and the IT accelerator, but I want to mention the iGEM. The iGEM, it's a project for undergraduate students which take, let's say, a prototype or an idea and actually make it to realization. And once they do it, it's in the world of biological, synthetic biology, and I won't go into it, but today we can engineer a lot of things in the lab, including genetic materials. So the student takes the idea, makes the prototype, and then they present it in the World Conference in MIT and compete on their, let's say, on different aspects of this project. And our graduate already won 3 gold medals in this competition. We also have a lot of courses, innovative courses that we structured, like the culture meet one and so forth, so students can enjoy the knowledge from that. And also we are teaching our students how to be innovative. We have course in innovation, lately, particularly in food. Again, Uri will talk about, but for instance, project like Algala falafel, how to make falafel from seaweed without the taste of sushi in it. It's very important, but also actually giving fast food, which is also a nutritional food. So just to give you an example, although it's in Hebrew, but the last year and a half, 2 years, we are on the news all the time, and our researchers are invited to different competitions because we are the expert in the food, in the field of food. As mentioned, we are the only one that produce engineers, food engineers in Israel. And we can see here different competition that our faculty were involved. And also in the news, we see the Algala falafel, like you see here. I don't know how much you can see all the details, but taking a falafel, making it from seaweed without the taste, as I mentioned, and also look like a falafel and very tasty. I tasted myself. So our students, once they finish their undergraduate studies, they go to the different companies in Israel. Of course, all the major food companies, but lately also to all the startup companies that are rising every day in Israel in this area. Going from that, the way that we introduce the industrial facility to our students are usually through our semi-industrial facility, which is very old. It was built in around the 60s. with very old equipment, and the building is no longer even safe for the student to be there. So in this building, we have actually all the equipment that is needed for the student to be acquainted with what will happen in the food industry. So they do courses there. So once they go to the industry, they will see the same equipment and will be able to be part and to be part of these companies and help in the innovation of the different food companies. So we understood that we need to change the center, we need to renovate it, and most importantly, to add very important features and aspects, technologies that were not be able to be addressed in the old centers, and actually to educate our students for the future, or like we say, for the biotech and food tech of tomorrow, and for the new innovation in food, like the culture meat or cultivated meat and so forth. So this is the center of Carrasco. It's named the Center for Food Innovation and Technology. And in this center, we're actually harnessing three major aspects: the food technology approaches, new equipment, new technologies that the students will have. Also, the Center for Synthetic Biology, as I mentioned, we need the raw material, but now we know that we cannot harvest it from animals, we cannot harvest it from our earth, we need to invent it in the lab. And we have the Center for Biomaterials, our material that are sustainable material, as you will hear from Ester later on, material that we can use for our product. So I won't talk about the sustainability because Ester will put more emphasis on that, but as all this event is around that, we need to save the world from damaging the world from pollution and from other sources that we are using from animals. So, and Ester will, as I mentioned, will talk about it. But in the center, we want to facilitate and to develop more technology that will talk about this food waste, that will give us new food like the culture meat and culture milk and so forth. If we look at the map of, for instance, the clean meat, or if no one knows what is clean meat, is how to make meat in the lab without killing the animal, for instance, if it's from cow or chicken. So we can see here that there are a lot of companies that today are engaged in this area all over the world. And if we look at very carefully, we can see already 1, 2, 3, 4, and there is another one company, which is my own, that are talking about the future meat and how to make this meat. So for instance, if I give an example for the company that I established just 3 months ago with the name of Metaphora. So in this area, we want to make meat in the lab without, as I mentioned, killing the cow. We take a specimen or just a sample, a biopsy from the animal, we grow the cell in a scale-up manner. So what is unique in this company? So what is unique in the company is how we grow the cells. If we can look at this, we have here a bead where the cells grow on it. This is the way that cells from animal can grow, and this is the only way. However, until now, all the company are using synthetic bead, which means that you cannot eat them, you cannot use them. So you need to take out the cell after you grow them on this bead. You need to take them out and then use the cell. You lose 20 or 30% of these cells. And also all the process is very expensive. So instead of taking synthetic bead, what we will do is, actually we have it already, we are taking beads that are made from protein that is isolated from a plant source. And this protein can give us also a higher nutrition value to the end product. And of course, the cells will be used to make the meat. This is just the example. If you look here, the cooked one. So this is the meat that we prepare. And together with Professor Ayelet Fishman and Maya Davidovich from our faculty, we engineered this construct because we needed not only the cells, we need also the fat, which Maya is very expert on that, and the fat will come from vegetarian oil, simple as that. not a bad fat like we say, but a good fat, vegetarian oil that we know how to produce it in order to have the fat that is necessary for this meat. So as I mentioned, this already was licensed and it's already up and running, and we hope to see the product in a very short time. So the Carrasco Center actually will house all these areas, and we will have an a wing for advanced R&D facility where we develop all this technology. We will have the industrial kitchen, and where the students will learn how and what is the ingredient that they need for every food that they produce, what will be the taste, the texture, and so forth, but also will be the face of the faculty, because there we will present our product. We will have a visitor center because we know that a lot of students and also a lot of citizens in Israel do not know exactly what we do. And this will be a way for us to introduce it. And we will have a startup center. Today, we have a lot of facilities, old facilities that we help startup, because not each startup can build its own facility, its own equipment, and therefore they can come and use this facility for their benefit, and of course pay for the equipment only, but can use it, and we can learn from them, they can learn from us, and also the faculty members can be as advisory to these startup companies that are being helped with our faculty. That's the scheme of the Carrasco Center. It will have two floors. The ground floor will house the semi-industrial, the blue one that you see here, the semi-industrial production facility with heavy equipment that some of them are in the conventional and industry, and others will be the new one that we will buy. And we have also a fermentation area. What does it mean? Here we will grow all the yeast and bacteria that produce all the protein and the factors that we need today for engineering the different type of food. And in the other top floor, we will have a food tech startup hub, which is located here, in which we will house different technologies, and the industrial kitchen, as I mentioned, and the visitor centers. We will also have labs, analytical labs that are needed for the student to learn how the process of food and how I detect different things in the food and analyze the food. And we will have a biopolymer packaging lab, in which Ester also will talk about it. We develop polymers that are more sustainable, polymers that can be used in food, but also for other health product. So I thank you very much for being with me again, and we of course later on answer all the questions. And now I invite Professor Ester Segal from my faculty to talk about her work and also the sustainable world, which is very important.
Thank you very much, Marcelle, and thank you again for being with us. So in my part of this webinar, I want to emphasize sustainability and what we do to enhance food sustainability. So let me present to you some of the challenges that are associated with food engineering and food in general. So just to give you some numbers, the main numbers that I want to emphasize are numbers that are related to the extent of food loss and food waste. More than 1.3 billion tons of food are being wasted each year. And if we count these numbers in terms of weight, about a third of the food that is being produced right now is being thrown without being open or being used. And if we go back to what Danielle said in the introduction to this webinar, we overuse earth resources, we overfish, we overgrow, And why do we do that? It's because a third of what we grow and what we produce is being lost and wasted. So we have to find means to keep resources better and to minimize food losses and food waste. And this is all relates to the research that I will emphasize in the next few minutes. Also, if we go by geographical areas, we can see that food loss and food waste is a global trend. You can see here in the slide here, you can see that, of course, China leads world waste and loss. But if we go per capita, you can see other players. For example, Australia caused the #1 loss and waste in food per capita. And you can see here in the list other countries that can be blamed, so to say, to this crisis. So this is one aspect of food sustainability that we must address, and we must find solutions to minimize this burden. Another burden that I want to emphasize, and Marcelle discussed it in her part, is about food safety. While we try to minimize food loss and food waste, we have to keep in mind and bear in mind that we have to keep the safety of food. We have to be sure that the food that we produce fits to all the careful standards of safety. Specifically, if we talk about foodborne diseases, so the slide here says that 1 person out of 10 each year gets sick due to foodborne diseases. And we are talking about 500,000 people yearly that die directly related due to the cause of foodborne diseases. So we want to address these two main issues. And in the research that we do in the faculty, we developed a couple of solutions that may be the engines behind the future. So the first one is to develop packaging solutions that not only contain the food in a passive manner, but also make sure that the food inside them is retaining its quality and, most importantly, its safety. So these are packaging that can kill the bacteria that grow on them over its shelf life. And another solution that we are working on are sensors or biosensors that can detect bacteria in the food package or already in our houses. So I will speak about it in the next few slides. So both these solutions that we are developing relates to a very interesting phenomena that we try and develop very innovative strategies on how to control bacteria on surfaces. So in terms of food safety and in terms of food packaging that can kill the bacteria, we actually want to repel bacteria from the surface. We want the bacteria not to reside on our food, not to reside on surfaces. But when we talk about biosensors that do detect bacteria, we want the bacteria to stick to surfaces so we can detect them. So let me briefly talk about the world of antimicrobial food packaging. So this is a project that got funded by the European Union. And the main innovation in this project is to incorporate natural materials that have antimicrobial properties, and they can exert their antimicrobial activity on the food. So we incorporate these natural compounds within the package and control, using different technology, the release into the package, into the food, And by that, we minimize the addition of preservatives to the food, and we control only the atmosphere around the food, and by that minimize and kill the bacteria that reside on the surface. And how do we do that? We take technologies that we actually borrow from biotechnology, that we actually borrow from drug delivery. So we develop small capsules that contain these natural extract, these natural materials, and we trap them inside these small nanoscale capsules. And these capsules next go into the packaging material, which can be of sustainable source, of course, and not just synthetic plastic. And when these small nanocapsules release their active cargo, they can kill all types of bacteria, fungal species, etc., that reside in food. And actually, the package do not even need to be in contact with the food to exert this action. So the technologies that we develop are not only limited to a lab, and this is what Marcelle emphasized. This is why it is very important to have a semi-industrial facility in an engineering department, so we can translate the technologies that we develop in gram scales to tons and even larger quantities. So here you can see different types of packages that are based on the technologies that I just described, that can already be produced on large scales and in real life. And what does this packaging do in real life? So here you can see some results of a very large bread experiment in which we packed bread loaves in the packaging systems that I described. And we found that we can extend the shelf life of the bread by 70% and more, retain the quality, the freshness of the bread, and minimize the growth of fungal species that produce toxins on the bread. And this would be very, very helpful and very important for preserving, for example, organic breads or other breads that do not contain synthetic preservatives. Moving to biosensors, and why do we need biosensors that can detect the presence of bacteria in food? Because if we remember the staggering figures that I gave you regarding food loss, some of the food loss is actually related to the growth of bacteria on this food. And also we must keep the safety of food and minimize foodborne diseases. So we want to have small devices that can tell us, is the food safe or not safe? This is for our personal use. They can be for our personal use. They can be employed in food factories. And today what happens is that the technology for bacteria detections are conventional, are centralized into a lab, and we cannot detect bacteria in real time and outside of the lab. Imagine to yourself that if I'm correlating it to what we have witnessed during the COVID-19 pandemic, that every kid now in Israel knows how to run an antigen test and test himself, that we would have such tools to allow us to evaluate the food that we are eating and minimize and save life by doing that. So we develop different biosensors, different technologies that can detect very sensibly the presence of bacteria, and we have already employed these technologies in different factories in Europe. So by that, I would like to thank you and switch gear to my colleague, Professor Uri Lesmes.
So good morning, everyone, and thanks for joining us. They say Necessity is the mother of all invention. Well, personally, to me, I'm the father of three, and that's my own personal necessity to actually try to affect the world for tomorrow, to try to leave to my kids a healthier environment, more options, a diverse and rich options of nutrition. And as you can see, the world is filled with challenges, and it's filled with malnourishment. And on the other side, you can see a lot of obesity in the world. You see the booming population. By the year 2030, about a third of the human population is expected to be older than 70. So even the word being elderly is becoming an offensive word, and people are now called seniors because we want to reach good, healthy life. And for that, we need to also account for the world that we live in, take into account that the world is becoming more and more populated. We are polluting the world, as we heard many, many times. And this is basically the necessity. But what we need to strive for is to offer safe, nutritious, and affordable options to the world. But before we move to the future, we need to look back into history. What makes us so special? Even this Zoom is made thanks to technology. How did we reach this technology? If we look at ourselves as Homo sapiens, we're just another species on this planet, but we are a very unique species. Why is that? Because for millions of years, we were just a bunch of monkeys, not more than that. But about 170,000 years ago, there was a leap. That leap is actually related to our interaction with food. We learned how to cook. And if you think about it closely, we share a lot of common points with a lot of different species: communication, being smart, thinking, sleeping. But we are the only species on this planet that cooks food. And we are the only species that actually lives off cooked food. And this is this big leap in our brain functions. So once we had enough calories, once we were able to fully exploit nature's potential to provide us with nutrients and with energy, our brain was able to develop. And this is actually the catalyst for the human evolution. But now when we look into present times and the challenges of present times, and we are trying to look into the intersection between us as humans and our food, we need to innovate, because we are right now facing a lot of challenges with the food sector. So if we look at the pathways that we're trying to educate the future engineers, which will really are our biggest pride, because they are the ones that actually will offer the new solutions of the world. So we're talking about mining for new ingredients, whether it is algae or very peculiar roots like maca, or even insects as potential alternatives to other ingredients that we put in our foods. We're talking about innovative technologies, using other ways to make our food, whether it is, for example, electricity, electric fields, pressure. We're talking about incorporating smarter technologies so we can monitor what our food has gone through before it came to our plate and analyze how it came. So think about how you get a package from Amazon, and it's completely different than how we know to track our food. So we're talking also about traceability. We're talking about authenticity, not getting bad food, getting foods that are coming from the right origin, knowing what was their origin. And we're talking about offering new products and new services to people. We're talking about 3D printing of meat, for example, which is a very innovative technology. We're talking about using cell phones. For example, the camera that we all have on our phones can be actually converted to analyze in the future, to analyze the composition of our foods and tell us a little bit more information about the nutritional values that we're about to consume. So we're talking about trying to innovate throughout our food chain. And for that, you need a lot of knowledge and a lot of tools. And this is where we try to play a role, because our mission as a faculty of food engineering is focused on research, education, and outreach. So we're trying to make the biggest impact that we can do to offer options that are healthier and that can help us prevent the world from becoming ill. Because if you think about it, offering solutions for sickness is a very, very noble cause, but we would rather keep the world healthy. So let's give you a few hors d'oeuvres to try on for size. So for example, trying to feed different people. So we need to understand, because our interaction with food actually comes through our gut. This is the first line of defense between us and the food, for better and for worse. So we're talking about the need to understand digestion. So all of these chemical analyses that we teach our students how to perform, so that we know nutrients, what happens to the nutrients, what happens to the non-nutrients, to other bioactives that are in our food. Are they released from food? What can they do in our body? So we're talking about different types of people, differences between female and males. We're talking about the differences between a child and an elderly person. And how can we learn all of this? Well, for us as researchers, we try just to recreate that in the lab. So this funny looking picture is actually a set of bioreactors that are programmed to recreate the human digestive tract. So we can actually try to feed it with different foods and then try to understand the digestion of foods. From that, we can try then to reverse engineer foods so that they can offer the right person what they need and not just what they want. And this innovative research is also part of the entire work done in our faculty that has also been part of the global ecosystem for food research. And this actually was a big honor that we missed because of COVID, of hosting the largest European scientific conference that was supposed to be here in Israel in 2020, but we held it only online. Sorry. Another taste could be the use of trying to mine the non-obvious suspects. For example, silkworms. One of the projects that was run in my own personal lab was actually trying to use silkworms as a rich protein source and to put it into food so that we don't have to really see the worms or feel their texture, but rather enjoy their nutritional benefits. So what you can see here is not a very appealing example, right? But if you were to grind everything and make it into a powder that actually looks like cookies, so think of a vanilla ice cream with cookies in it, and then we actually let some people try it on, and they said, hey, it's simply tasty, because food has to be first and foremost palatable. It has to be tasty before being nutritious, before anything. So this is part of what we do. And we also try to educate students. And as you can see here, there's a lot of activity there too. Our faculty is actually, as said more than once, we are the only ones who train engineers. And this is actually a national mission for us. And we try to repeatedly do that, not just nationally, but also internationally. And you see here 3 teams of students that actually competed in international programs, competing with other universities over challenges that were put forward by companies like Danone, like PepsiCo, trying to ask people for innovation. In this case, for example, this is the team that developed the algalafel. This team actually offered to use viruses to control bacteria in juices and therefore reduce the spoilage of juices. And this is our latest innovation, trying to generate a vegan option for cheese spread. So a cheeseless cheese spread, just made based on oatmeal. And as you can see, they keep winning first prizes. And how is that involving us globally? So we're not just trying to innovate locally, we are also engaging internationally. So we're part of the EIT, which is the European Innovation and Technology Authority. They have a specific program for food innovation, and we also had the Food Accelerator Network. And as you can see, this is basically a pan-European program that spans a lot of different universities and major companies like PepsiCo, Givaudan, and Danone, Nestle, universities like Cambridge, ETH Zurich, Technion, TU Berlin, and more. And before I finish off, I want to leave you with another innovation that came through our door that you can see here, trying to think of a steak. What you see in front of you is a steak. It's redefined meat. It's a company that went through the EIT Accelerator program that I have the pleasure of being part of, that runs in our department. And they basically take plant-based proteins, a 3D printer, and they print out steaks. And I hope that leaves you with a taste for more innovation. And this is a great opportunity to thank you all for your attention. And we'll be happy to take questions in a few minutes. Thank you very much.
Thank you so much, Marcelle, Esti, and Uri. This was super interesting. I am seeing some questions come up here. So again, I just want to remind everyone to please use the Q&A button on the webinar screen to post your questions, and we will get to as many as we can. It is now my pleasure to welcome Sally Rosenfield, the ATS Director of Leadership Giving for New England, who is going to moderate the Q&A session. Sally, so nice to have you here.
Great. Thank you, Danielle. And thank you to all of our speakers. There are a lot of questions, so let's get started. The first one is, while organic, local, and farm to table implies fresher, tastier, and healthier foods, engineered foods can imply mass-produced, less nutritious, and cheaper. From purely a perspective point of view, do you anticipate a difficulty in getting people to embrace engineered foods? For example, cultured or 3D printed meat, insects, and silkworms.
Can I take this?
Mm-hmm.
Well,
Feel free.
actually, that's the biggest question. People anticipate that people will have to embrace some of these innovations because there's no other option. People with low income will not be able to afford steak, so they will have to have an alternative. And the more we offer diverse options and we support with research that they are safe, that they are wholesome, people will start to trust them. Just remind ourselves that the COVID vaccine was at the heart of a lot of debate, whether it is safe or whether we are not running ahead of ourselves. And thank God science actually provided a very good solution to humanity to fight off COVID. So the same will probably apply to food. The question would be probably a matter of time, whether it is 1 year, 5 years, or 10 years.
I can add to that that each company today are taking seriously this part of educating the customers for these changes. And if you don't know what you are talking about, or you don't know how it look like, I myself tasted part of this food. And if you taste it, you will see that actually it's similar. It's really, really like the real thing, especially in meat, the one that I tasted, but also I tasted the, for instance, the spread that Uri talked about. And if one did not tell me that it comes from vegan source, I would not believe it. So it will take a bit time, but we were educated with a lot of things that changed our life during the years, during the decade. And we adjusted to the internet, we adjusted to the cellular phone that we didn't have, and the different car and transportation. So if we need and if we must, we will adjust, because that's what we will have in the future. We don't have any other solution for that.
Thank you. Another question is, do you look at eliminating a reliance on fossil fuel in food packaging?
Oh, that's an excellent question. More than $1 million worth question. So definitely, I didn't talk about it, but as of today, people have produced more plastics than the natural mass that exists on Earth. Imagine to yourself that we are basically drowning in plastics. And the plastics that we have produced, plastics are new materials. They've been invented around 100 years ago. And in this past century, we have synthesized and produced so much plastics, and none of it was actually degraded over these past years. So we flooded our world with materials that are not degradable, that are not part of nature. So first of all, we must find solutions for plastics that are degradable. We must use sustainable sources instead of fossil fuels for producing plastics, so using more naturally derived materials for plastic, and we must use less. I think what it also relates to the question before, we've become very, very spoiled. And this is not sustainable. We cannot use package over package over package and just use something for 3 seconds and then throw it away. This cannot
throw food.
We throw food in the package. Everything together adds up to resources that are wasted and cannot be retrieved back. So definitely this is something that we are working on also in our department, research in my lab, research in the lab of Professor Maya Davidovich is to use waste in order to produce packaging solutions.
That's actually a great segue to our next question. What is the proportion of food waste? Is it spoiling because we didn't eat it at a meal and so we threw it away, or are you talking about spoilage in general?
So let me take this question. So food waste and food loss goes throughout the food chain. It starts actually in the field already, before the food even gets to the truck to take it further. So the farmers themselves lose a huge portion of the food. And then during transportation, the food is being lost due to natural spoilage. And then when it comes to the factory themselves, the food industry itself, spoilage occurs that. So if I divide it into portion, I would say that to about 1/3 of food waste we are responsible as consumers, and 60 to 70% occurs already before it gets to our plate. But we have a significant role in that as well.
Thank you. The next question is, when will any of the meat technologies be commercially feasible?
So actually there is one commercially available in Singapore. Singapore is the only country for now that approved such type of culture meat. It will take a bit time, but depend if we are talking about real culture meat, real meat, which means culturing cell from animals and growing the real meat with the bloody look and all the taste. Or we are talking about vegetarian source of meat, which is much easier, like a ready-defined meat, the example that Uri mentioned, the accelerator company that succeeded very much, and by the way, raised more than $100 million. So if I'm talking the real culture meat, I think that at least the diced meat or the minced meat will hit the market in 5 to 6 years in a lot of markets all over the world. And the cut of meat, or what we know as a steak, this will take, to my opinion, a bit longer because we still need to figure out the cost of this product, and it's a very expensive, even if it was reduced, by the way, 10 years ago, 200 grams of steak cost around 1,000 or $1,500 per this steak. And today we are talking about, companies are talking about $200 per steak, but you know, it's still expensive, you won't pay it. So we need to reduce this cost, but for the diced meat, we are very, very close. Some product will already hit the market 3 to 5 years, and some will around 5 years.
Okay, next question. Do your efforts take into account ethnicity, customs, and tastes? Do you offer opportunities to customize?
Well, that is, I think, one of the largest goals for the entire food sector. Trying to offer tailored foods, trying to personalize food options, trying to find rich options that we can cut and paste and build however we want, or just if you think about it, every person can make their own, or every factory could make something that's precise for an individual. That is something that is being addressed by various studies, also here on campus, trying to find the ways to really tailor foods to specific individuals, or even just to specific groups of the populations, like the project I mentioned about the elderly population, or even trying just to offer very, very specific strata of the population with specific foods, like people with celiac, trying to offer them better solutions or richer diversity. So the option is on the table, as we say.
I think it also relates to food ethnicity that you mentioned,
Yeah.
that we don't want to eat just Cheerios.
Yeah.
Oh.
And that's exactly why we need diversity. That's why I think the jackpot for Al Galafel was. The competition was actually European. At first, we were actually quite hesitant. Will people in Europe really relate to the concept of falafel? And they took first prize because it's an ethnic food, but you know, people are looking for more options. As Esti mentioned, nobody wants to eat Cheerios their entire life, or not even if they taste like heaven. You probably get fed up. So it's a matter of choice.
And we have a couple of questions on this topic. Will this meat be kosher? Because the cell, as you mentioned, the cells will grow from a biopsy taken from an animal, a living animal. And as we know, with kashrut, you have to eat an animal that has been slaughtered.
I can answer that easily, because the Yitzhar rabbis in Israel addressed me asking my opinion, and also to learn about this culture meat, because this will be a huge problem for the religious rabbi to decide whether it's kosher or not. And the three facts are, okay, the source of the cells. So if they come from cow, it's okay. If they will come from porcine, it's a problem. But okay, so if it comes from cow, will it be kosher or not? We don't have blood, okay? We don't kill the animal. You know, in Judaism, the way that you sacrifice the animal is very, very important. That's what makes us different from even the Islamic world. So there is no sacrification, there is no blood, and therefore only the raw materials themselves, and you know how we produce it in the lab, cannot by themselves say if it's kosher or not. According to what I understand, and I told them, it's kosher. Actually, it's not only kosher, it's something that you can eat, like dairy and meat, which of course religious people do not mix. You can mix it, because again, the major problem usually in that area is the blood, and we don't have any bloody, or at least real blood coming from the animal. We create the blood only to give us the texture and the colors, so people will perceive this food, but it's not a real blood. So they will need to debate it for a long.
And you eat kosher, Marcelle.
And I eat kosher. I eat kosher, and by the way, I tasted it in my
And
lab.
that's even before you even thought about the option of the cultured milk.
Yes.
So can you make the cultured
Mix
milk
with
with the cultured meat?
So, you know, now no restriction, thank God. No restriction. I could eat a hamburger with cheese on it. Just the cheese is not a cheese, and the hamburger is a hamburger just without the blood. Very complicated world that they will need to discuss it very carefully. I'm sure that they will come with a conclusion that they don't have a conclusion.
Completely science fiction.
Science fiction. Actually, it's science fiction.
Yes, it certainly sounds that way. Okay, next question. Can the antibacterial and antimicrobial technology for packaging be extended to other surfaces such as kitchen counters?
Absolutely. So it can be used for and translated to hospital settings. Imagine to yourself fabrics in the hospitals, beds, linens, etc. It's easily translatable to other technologies, and we are working now on translating these smart nanocapsules also for agriculture. Instead of using synthetic pesticides to treat plants and crops, we are trying to use these smart capsules in order to properly treat in a sustainable manner crops without damaging the soils, without polluting the soils, etc. So it's definitely translatable, and we are working on that.
I want to add in this point, actually, this is the best example, this and the culture meet how our faculty, which is the biotechnology and food engineering, because we are situated near each other. I came from the biotechnology world. I came from tissue engineering, from cancer drug delivery. Ester came from the polymer world, okay, from designing material for a certain, let's say, scientific area. But look how wonderful it is today. We can take the same solution, okay, that we are using for one purpose to use it for another purpose, from one illness to healthier solution. And you can translate it to so many areas just by changing the name, not the bacteria even, okay, not even the system. When I talk about culture meat, for instance, I grow cells for cell therapy, to replace a piece of the heart, to replace a piece of the liver. What's the difference between a piece of a muscle for human health and the one that needs to eat it? Okay, the same technology, just by the way, simpler according to the regulation that we need to face and meet, because we know that once we want to transplant something, we need to be according to the FDA regulation, a very strict regulation, very expensive until we get it. On the food, it's the food regulation, which are
also
different.
by the FDA.
Yes, it's by the FDA, but a different regulation because we eat it through our mouth, and we have a digestive tract that can kill a lot of, let's say, contaminator, and we can adjust it. But again, a solution in biotechnology on the help for the food and vice versa, which is unique. And that's why our department, people are moving from biotechnology to food engineering to biotechnology. We have the knowledge to do both.
Great. I see that it's 1 o'clock now. So I'm going to say thanks to you all for a fantastic conversation. And Danielle, back to you.
Well, just in time for lunch. I don't know if I want to start with lab-grown meat, vegan cheese, or bugs, but thank you so much to Marcelle, to Esti, and Uri, who have described so clearly how the Carrasco Food Tech Center will transform Israel and will have an impact on the world. I am proud to support an institution that is able to tackle these big challenges facing humankind and give us hope for a sustainable future. And thank you to all of you for joining us today. If you'd like to find out how to support this amazing center, please reach out to your local ATS representative or send an email to info@ats.org. This program has been recorded, so you will receive a link to the recording in the next few days. Be well. Thank you.